Hello people and welcome to this video. In this video, we'll be working on the grade 12 Mathematics paper 1 for September 2023, and this is specifically from the Mpumalanga province. Also note that this paper is worth 150 marks as always, and the time allocated is 3 hours. Okay, so with that being said, let's get into this video. Question 1 says 1.1, solve for x, and we have been given this equation. So the idea here is that you have two values being multiplied and they give you 0. So it's either that the first is equal to 0, meaning 3 minus x is equal to 0, or the second is equal to 0. And those are the only ways that they could multiply and give you 0. If you transpose x, x is going to be positive, so x is equal to 3. Or here again, transpose this negative x, it's going to become positive, so x is equal to 2. Okay, so x equals 3 or x equals 2. Moving on to the next question. Question 1.1.2 says we have to solve for x correct to 2 decimal places. Okay, so this is a quadratic equation, and we can see because the highest exponent on x is 2, but it's not in its standard form. It should be in the form of ax squared plus bx plus c equals 0. So let's transpose that 2 so that the right hand side is equal to 0. So we'll have 2x squared plus 7x minus 2 is equal to 0. Okay, and now that it's in its standard form, we can solve for x using the quadratic formula since we are going to have irrational solutions. The quadratic equation looks like this. Okay, and from this we can see that a is equal to 2, b is equal to 7, and c is equal to negative 2. So let's go ahead and substitute, and then we're going to find out what the values of x give us. So let's go ahead and start with the positive. Okay, and our first solution is 0. Now that third decimal of 5, it's going to round up, and so it's going to cause that 1 to become a 7. So 0.27, or x is equal to, and we'll simply just change that sign to a negative. So x is equal to negative 3 point, and again that 5 is going to round up that 6 to 7, and so we have negative 3.77. And these are our solutions. Moving on to the next question. Question 1.1.3 says we need to solve for x where 4 plus 5x is greater than 6x squared. Now from this you can see that this is a quadratic expression that we have. So we can transpose these, okay, and take them over to the right hand side. So we'll have here, we just have 0 is greater than 6x squared minus 5x minus 4. But now it kind of looks awkward. So let's rewrite it so that the 6x squared minus 5x minus 4 comes first. And when we are looking at this versus the 0, do you notice that the inequality is facing the 0? So just rewrite it facing the 0. Okay, and now we just have to factorize this expression. So open up two brackets because it's quadratic, and we will say we need the factors of 6x squared. You can choose to use any method that works best with you. So I'm going to use a method called the cross method. So with this method, I'm going to take the factors of the first term. So we could look at 6x and x, and then the factors of the second term, which could be 4 and 1 or 2 and 2. But it has to be put in a way that it gives us negative 1 in the middle. Now notice this is negative, meaning one of these numbers, one of these factors need to be negative. Now currently looking at the factors, it's going to say some number minus another number since one of these factors will be negative. So we'll have a positive and a negative. If we multiply like this, you see that we get 12x and we get 2x. There's no way that 12x and 2x can give us negative 5x. So let's change the factors. And you change the factors gradually. So we can decide to change this from 2 and 2 to 4 and 1. Okay, so now we would have a 6x and a 4x. But you see that 6x and 4x because we know that they would still subtract. We're going to end up with a 2x, so that's not negative 5x. Okay, another thing you could do is switch these around. Instead of 4 and 1, you could change it to 1 and 4, but you can see how that is not going to work out. That's going to be 24x. Okay, so let's leave it at 4 and 1 so we don't complicate things. Now, the next thing we can do is change these factors. Instead of 6x and x, we could change this to 3x times 2x. That's what gives us 6x squared. So if you say 3 times 1, we get 3x, and 2 times 4, we get 8. So that's 8x. Okay, so these two, they can actually give us 5 because we know one of it should be negative, one should be positive. Now, which should be negative so that the number that it adds up to stays negative 5? You would give the negative to the bigger value. Okay, so that stays negative, this will be positive. So how we know which to give the negative to is, how did you get 8? We got 8 by saying 2x times 4. So that is minus 4, and this is positive 1. Okay, and there we go. 3x minus 8x indeed is negative 5x. So our factors are 3x minus 4 and 2x plus 1. And there we go. We've factorized this expression. Okay, and now we have to find our critical values, okay? Those points that help us find out where our solutions are. So the critical values will be found by equating this to 0, okay? It's like saying this is equal to 0 or that is equal to 0. So that is going to end up being 3x minus 4 equals 0. You would transpose that negative 4, and then you divide both hand sides by 3, getting x to be equal to positive 4 over 3. Or the other critical value is 2x plus 1 equals 0. Transpose the 1, so it's negative, and divide both hand sides by 2. So x is equal to negative 1 over 2. Okay, so these are our critical values. And now to solve for x, we are going to draw down our parabola. So our parabola, seen from this, is a concave parabola because the value of a is greater than 0. So our parabola would look like this. And now we know where our critical values are as well. Our critical values are negative 1 over 2, so that goes here, and 4 over 3. Okay, now the inequality is specifically asking for where this graph, the y values of the graph, are less than 0. Looking at the y values of a graph, the y-axis, here we have positive y values. And you see that the places on the graph with positive y values are all the points that lie above the x-axis. All of these have positive y values. So we're not going to consider these ones. We'll leave them out, and we're going to now look at the places where we have negative y values, and that is below the x-axis. So we're going to highlight every part of the graph that lies below the x-axis, which is all through here. Okay, and now we don't really need that y-axis anymore. Okay, so now we can line these up to the x-axis so we can better understand where these x values are. So compared to the critical values, looking at negative 1 over 2 first, these are values that are on the right-hand side of negative 1 over 2. And compared to 4 over 3, these are values that are on the left-hand side of 4 over 3. So these are values that are moving towards the left of 4 over 3. So you can see that they are values that are between negative 1 over 2 all the way to 4 over 3. Okay, so we will tell them that this is where x is greater than negative 1 over 2, but less than 4 over 3. So greater than negative 1 over 2, but less than 4 over 3. And that is our answer. Question 1.1.4, we have to solve for x in this exponential equation. Okay, so with this equation, do you notice we have an exponent of x here, an exponent of x here, and here the base is 3, but here the base is 9. But the thing about 3 and 9 is, or really the thing about 9 is, 9 can be written as a base of 3. So we can rewrite 9 as 3 to the power of 2, but then it still has an x multiplied to it. And then at this point, you'll notice that you have a base to the power of an exponent times 2, and you have that same base again repeating itself to the power of that same exponent. So there's a repetition of 3 to the power of x here. So this is something that we can rewrite as a quadratic equation. So let's go ahead and transpose this. Let's take this over to the left-hand side. So we have minus 10 multiplied by 3 to the power of x, and then plus 9 is equal to 0. This is a trinomial, and we'll be able to recognize that it is a trinomial if we replace the repeated value with k. So the repeated value is 3 to the power of x. We also have it here, 3 to the power of x. Let's let k be equal to 3 to the power of x. So when you replace this with k, you see that's 3 to the power of 2x, but you can't just write it as x times 2. So if this is now k, that's k squared. So k squared minus 10, and then this is times 3 to the power of x, which we're going to call k, and then plus 9, and we have a quadratic equation. So let's factorize and solve for k, and then we can find out exactly what x is. So this is going to be, we open up two brackets, k multiplied by k gives us k squared, and then factors of positive 9 that can give us a negative 10. Okay, because this is positive, they both have to be negative to ensure that the middle stays negative while the last term stays positive. So that's minus 9 and minus 1. Okay, this is what we have. And so this means that k is equal to 9 or k is equal to 1. But remember, we're trying to solve for x. We know that k, we let k be equal to 3 to the power of x. So we'll substitute this back in here. So 3 to the power of x is equal to 9, or 3 to the power of x is equal to 1. Okay, so with this one, you see that the bases can be made the same. So this is 3 to the power of x equals 3 to the power of 2. Therefore, x is finally equal to 2. And here, 3 to the power of x is equal to, how can we rewrite 1 as a base of 3? Anything to the power of 0 is 1. So this is 3 to the power of 0. Therefore, x is equal to 0. So these are our two values of x. X is equal to 2 or x is equal to 0. Moving on to the next question. Question 1.2 says solve for x and y. So we have been given these two equations. Now, straight away, we can take this equation and just form our first equation. So y is already on its own. So we can just transpose the negative 2x. So we'll have y equals positive 2x minus 1. And we can call that equation 1. And then equation 2 is still y squared minus 3x. Y is equal to negative 2. And now to solve for x, we can substitute equation 1 into equation 2. So wherever we see y, replace it with 2x minus 1. So we say y squared. So we'll say 2x minus 1 all squared. And then that's minus 3x, and then multiply by again 2x minus 1, and is equal to negative 2. Okay, let's just distribute. So we're going to FOIL that. You can say 2x minus 1 and 2x minus 1, but always use short methods because it helps to avoid mistakes. So we'll square the first term, that is 4x squared, square the last term, that is positive 1. Then first term times second term, that's negative 2x, times 2 is negative 4x. Okay, we're done with that. And now distribute here. We're going to get negative 6x squared. Negative 3x times negative 1 is positive 3x. And you see that we're going to have a trinomial here, okay, because we have an x squared remaining and we have x and then a constant. So let's just transpose that too. So plus 2 equals 0. So this is equal to, we're going to say 4x squared minus 6x squared, and that gives us negative 2x squared, and then negative 4x plus 3, that's 3 minus 4, which is minus x, and 1 plus 2 is 3, is equal to 0. Okay, so this is still negative. We need it to be positive so we can better factorize it. So we can divide or just multiply both hand sides by negative 1. Okay, so times negative 1 on both hand sides. So we have 2x squared plus x minus 3 is equal to 0. And now to factorize. So I'll use the cross method again. So what times what gives us 2x squared? Well, that's 2x times x. And what times what gives us 3? That's 3 and 1. Okay, and just putting it like this would actually work out, because when we multiply here, we get 2x, and here we get 3x. But notice that the 3 was negative, so one of these numbers should be negative. So which of these should be negative so that we remain with positive x? You have to make the smaller factor negative. So negative 2x and then plus 3x. So that would give us positive x. Okay, now looking at negative 2x, how did we get that? We got that by saying 2x times 1. So the 1 takes the negative and the 3 takes the positive. So our factors are 2x plus 3 and x minus 1 equals 0. Okay, and now we can finally solve for x. So here solving for x, you'll say 2x plus 3 equals 0, transpose that 3 so it's negative, and then divide both hand sides by 2, so you end up with x being equal to negative 3 over 2. Or here, x is simply equal to 1. So we found our values of x, and now we can substitute that in y. So y's equation looks like that. Okay, since this was already an equation with y as the subject, so we'll say y is equal to 2 multiplied by negative 3 over 2 minus 1. So that is, those 2's will cancel in the numerator and denominator. Negative 3 minus 1 is negative 4. Or y equals, and we say 2 times 1 minus 1, that's 2 minus 1, which is 1. So there we go. These are our answers. When x is equal to negative 3 over 2, y equals negative 4. And when x is equal to 1, y equals 1. And that is our answer. Question 1.3 says, if x over y plus y over x is equal to 17 over 4, we need to calculate the two values of x over y. Okay, so find the values of x over y. You will notice something about this equation. X over y and y over x, very similar. So x over y, and let's just use this example. Let's say we had m, right? So m as a fraction would be m over 1. If you took m and you found the reciprocal of m, it would be 1 over m. Now, they don't represent the same thing. They're not equal. But do you see how we were able to look at this and then express the reciprocal like this? Meaning just swap the numerator and the denominator. And that's what they did over here. So the same way this is just m over 1 and this is 1 over m, we could actually express this like this. So you see the x over y, we'll leave that. And the reason why is because we want to solve for x over y. So let's leave it as x over y. But we can now rewrite this so that it also says x over y. But we would rewrite this as, so plus 1 over x over y. Okay, following this same example, if we have m, then the reciprocal of that is 1 over m. So that's 1 over this same value. Okay, so this is what our expression would look like. Let me actually just rewrite the first expression first, and then this is what it's going to simplify to. Okay, so it's now x over y plus 1 over x over y is equal to 17 over 4. Okay, so you have a value and then 1 over that same value in the denominator. This is an expression that can become quadratic. It just looks funny right now, but look at what we can do so that we can easily see that. We have a repeated value. So when we have repeated values and that value just looks a little intimidating, so what we can just do is give it an arbitrary value like k. So we're going to say, let k be equal to x over y. And so we have in place of x over y, so now it is k and then plus 1 over k is equal to 17 over 4. Okay, so in this equation, in order to solve for k, the problem right now is we have k in the denominator. So we can sort this out by multiplying both hand sides of this equation by k. So times k and times k. And now we have k squared. Now, before multiplying this, remember how I said that this is going to become a quadratic equation. Okay, so when you multiply these two together, they give you 17 over 4k. But if you multiply these two, the k's cancel. So clearly that's going to be the 1, the constant. And then this is going to be that value with b, okay, that coefficient of k. So let's transpose that. It's now negative 17 over 4k. And then that multiplies and gives us a 1 because the k's cancel. Plus 1 equals 0. And there we go. We have a quadratic equation. And we can just solve for k immediately. You can factorize. It feels like it'll be a lot of effort because we have like 17. So let's just use the quadratic formula. We can do that. Okay, so of course, this doesn't mean that we may not be able to factorize. We can. If we just get rid of this 4 in the denominator, so this stays a value that we can actually achieve. Okay, so if we didn't use a calculator, we could have just said, let's multiply both hand sides of this equation by 4 so that we can get rid of that 4 in the denominator. So we have 4k squared. It's kind of risky to do this because you're kind of like wasting time because it may not factorize at the end of the day, but we'll see. But I doubt that it wouldn't because they said x over y. Okay, so 4k squared. And then when we multiply here, you see that the 4 and 4 will cancel. And we have negative 17k and positive 4 equals 0. Okay, and now we can factorize. The middle is the only negative, so we already know both factors will be negative. Okay, and so we're looking at 4k times 1. Okay, and this is a simple one. To get that negative 17, just make this 4 and make that 1. So 4 times 1 give us 4, and we know these will both be negative. So 4k times negative 4 is negative 4k, and this should be a k. Sorry about that. That should be k. So, and then k times negative 1 is negative k. So you see how that gives us negative 17k. So it has factors. It's 4k minus 1, and it's k minus 4. K minus 4, and then it's equal to 0. And now we can finally solve for k. So it means that k would be eventually equal to, if you equate that to 0, k is finally equal to 1 over 4, or k is equal to positive 4. And now we can go ahead and take what k was, what we said k equal to. That was x over y, and we'll just substitute it back in here. So this means that x over y is equal to 1 over 4, or x over y is equal to 4. And those are our two values of x over y. And that is it for question 1. Question 2 says 2.1, consider the following quadratic sequence. And we have a couple of terms here, and they want us to show them that the nth term of the sequence is equal to this. Okay, so let's rewrite our sequence first, and let's find the first difference. So the first difference would say 280 minus 319. So that's going to become negative, and we can just say 319 minus 280, that's like 300, and then plus 19. 300 minus 280 is 20, so 20 plus 19 is 39. So that's negative 39. And then we have to say, you can just say 280 minus 243. So that's 80 minus 43, which is 37. So negative 37 that we have. And then again, we're going to say 243 minus 208. But at this point, because it is a quadratic sequence, we don't really need these other parts. We really just need these two, and then the second constant difference. So the second constant difference, you can see from negative 39 to negative 37, we are really just adding 2. So the constant difference is 2. And here's the reason we don't really need the rest, because we just need the first terms of the quadratic pattern, the first difference, and the second constant difference. This one is constant, so it will keep being 2. So at this point, you're going to just equate these with the following. So 2a is equal to the first term here, 3a plus b is equal to the first term here, and then a plus b plus c is equal to 319. Okay, so 2a equals 2, and then if you divide both hand sides by 2, a is equal to 1. And then 3a plus b, so that's 3 times 1 plus b equals negative 39. So b equals, that is 3 times 1 is 3. If you transpose 3, negative 39 minus 3 is negative 42. Okay, so b equals negative 42, like they also have. And then a plus b plus c. A is 1, B is negative 42, plus C equals this number 319. And so 1 minus 42 is negative 41. So C equals 319, and this will get carried over. So it becomes a positive 41. So already with the 1, it gives 320. And then with the 40, it gives 360. So C equals 360. Okay, and so our Tn formula is finally Tn equals n squared, because A is 1 plus Bn, and so B is negative 42, so negative 42n plus C, which is 360, just like they told us it would be equal to, and that is our answer. Question 2.1.2 says determine which term has a value of 0. So which term? So these are term values, and their positions are term numbers. For example, here this is the second term. So the position is 2, but the term value is 280. They want us to tell them which term has a value of 0. So which term, meaning in place of Tn, we're going to substitute 0. So our equation is going to be, we can just say n squared minus 42n plus 360 is equal to 0. Okay, so this is what we have, and we have to see whether they are factors or not. If it can be factorized, you factorize it. If you cannot, use the quadratic formula. Now, you can use the quadratic formula for something like this. Just don't show that, okay? Make sure that you include your factors just in case there's a mark allocation for the factors. So we're going to pull up our quadratic formula and say negative b, so that is negative 42, plus minus the square root of b squared, negative 42, all squared minus 4ac, so a is 1, and c is 360, all over 2a, so that's 2 times 1, which is still that. Okay, so we see that the first value for n that we get is n equals 30. So what does that say about the factor? The factor was n minus 30. And then here we can change that to a minus, and we can see that the second one is 12. So that means n was equal to 12, and the factor is n minus 12. Okay, so that's what we would have done in order to solve for x. We would have said this is equal to 0 and transpose that negative 12. Okay, so these are our two values. N is equal to 30 or n is equal to 12. Okay, so these are answers and they are both valid. And the reason they are valid is because they are not negative, neither are they fractions. So that is our answer. And moving on to the next question. Question 2.1.3 says, which term in the sequence will have the lowest value? So which term, meaning we're finding the value of n where we will have the lowest value, or in other words, the minimum value. So how do we find the minimum value? In this case, this is a quadratic pattern. Okay, so it has a Tn formula that is a quadratic expression. So we just need to find out the value of n for which this expression is a minimum. So you can either derive this expression, or you could use this method where we'll say that n is equal to negative b over 2a. I would rather go with this at this point because it's going to get you the answer straight away. So n equals, I'll say negative b over 2a. This in a parabola, this is a concave parabola. This will help to find the x value of that turning point. Now you see that that is where our minimum will be. So it has these values, high y values, and then the lowest that it reaches is this value. So that's the minimum. So it's really just find the x value of the turning point. Okay, so we use this equation, and so we'll say n is equal to negative, and b is negative 42 over 2a, and that's times 1. So that's going to be positive. So what is 42 divided by 2? That is 21. And there we go. That is where n has a minimum value at n equals 21, and that is our answer. Question 2.2 says 3t, 4t minus 1, and 23 are the first three terms of an arithmetic sequence, and we need to prove that t equals 5. So find the value of t. Okay, they told us that this is an arithmetic sequence. And what do we know about an arithmetic sequence? It has a common difference or constant difference that would be exactly the same. Meaning, this is T1, T2, T3. If we say T2 minus T1, that should be exactly the same as T3 minus T2 since they both represent the common difference. So we'll say 4t minus 1 minus 3t, and this is equal to whatever 23 minus 4t minus 1 gives us. So we're subtracting by two terms, so say minus the 4t and then minus the negative 1, which will become plus 1. And so 4t minus 3t is t, so this t minus 1 is equal to, and we have here 23 plus 1 is 24, so it's 24 minus 4t. Transpose the negative 4t to get positive, and it adds to this t, so that's 5t equals 24, and this negative 1 goes over and becomes positive, and it's now 25. So if you divide both hand sides by 5, t is indeed equal to 5, and that is our answer. Question 2.2.2 says calculate the sum of the first 50 terms of the series. So it's this same series, the arithmetic, and we know that to find the sum of series, we can either use this formula or we could use this formula. Okay, now in this case, it might be a hassle to go and find term 50. So let's just go with this because we can actually find the difference and we can find a here. They told us it's 50 terms, so we know that n is equal to 50. It's the sum of 50 terms. Okay, so we can find a here by looking at the first term. A is the first term, but we already know what t is. So we're going to substitute t equals 5 into t1. Okay, so let's go for this formula. Okay, so we are finding the value of a. A is t1, which was equal to 3t. So this is simply just going to be 3 times 5, which is 15. And then the difference. The difference, we have two that we can use. You see, when we said term 3 minus term 2, this is what it simplified to. And when we said term 2 minus term 1, it simplified to this. So this is easier to use. We'll say t minus 1, that is d. So d equals t minus 1, which is 5 minus 1, and that is 4. Okay, so we've got the difference, the first term, and so we can find the sum of 50 terms. This will be equal to 50 over 2 multiplied by 2a, which is 15, plus 50 minus 1 multiplied by 4. And let's find out what the sum of 50 terms is. And that gives us 5,650. And that is it for this question. And that is it for question 2. Question 3.1 says, the following geometric series is given, and this goes to 15 terms. Write the series in sigma notation. So to write the series in sigma notation, we need the general formula first. So because they said to 15 terms, then this starts at term 1, 2, 3, and then all the way to 15 terms, meaning n is equal to 1. It starts at n equals 1 and ends at 15 terms, so at n equals 15. So let's just find the Tn formula for this series. Okay, so the value of a is 4, and the value of r is, so 36 divided by 12 is 3. 12 divided by 4 is also 3. So the ratio is 3. So the general formula for geometric series is Tn equals a multiplied by r raised to the power of n minus 1. So this is Tn equals 4 times 3 raised to the power of n minus 1. And so written in sigma notation, this is the sum of the series starting at n equals 1, ending at 15, of the series with the general form 4 multiplied by 3 raised to the power of n minus 1, and that is our answer. Question 3.1.2 says, calculate the series. So what is the sum of the series to 15 terms? So we know that it ends at 15 terms, and we're going to use a specific sum formula depending on what the ratio is. The ratio is 3, so this is the value where r is greater than 1. So we're going to use the sum of geometric series formula, which looks like this. So it's a multiplied by r to the power of n minus 1 all over r minus 1. Okay, and of course this is where r is greater than 1. So we're going to substitute our value of a and r and n. So we're saying the sum of 15 terms is equal to the value of a is 4, value of r is 3. So this is 4 multiplied by 3 raised to the power of 15 minus 1 all over 3 minus 1. And let's find the sum of this series. And the sum of this series is 28,697,812. And that is our answer. Question 3.1.3 says, is the series convergent? And we need to provide a reason for our answer. Is the series convergent? Well, look at the ratio. It's 3. Okay, so this series, because it keeps multiplying by 3, the previous term multiplies by 3 to get to the next term. It's just going to become infinitely big. It's not reducing and heading to a specific number. It's not converging. So for it to converge, you see that r was equal to 3. For it to converge, then r should be greater than -1 but less than 1. And you can see from this that this is an improper fraction that we should have. So we see that 3 will not lie in this range. Okay, it is not greater than -1 but less than 1. So we can finally just tell them 3 is not greater than -1 but less than 1. Therefore, the series does not converge. Okay, so this r value is not between -1 and 1. Therefore, the series does not converge. And that is our answer. Moving on to the next question. Question 3.2 says, the sum of an infinite geometric series is 13.5. Okay, the sum to infinity is 13.5. And then they tell us that the sum of the same series calculated from the third term is 1.5. Okay, and they want us to calculate the value of r if r is greater than 0. Let's look at the information they've given us. The sum to infinity of a geometric series is 13.5. So this is starting at term 1 all the way to term infinity. Okay, so as we keep going, that sum is equal to 13.5. But then we have this same series, so it's going to also look like we're going to have the same timeline or similar one. Now in this series, right, it's the same series. They are starting this time from term 3. Okay, so from term 3, that series, the sum of the series there is equal to 1.5. So here we have the sum to infinity and the sum to, well, it's still the sum to infinity, it's just starting from t equals 3. We're going to have to find a way to express this. So this sum to infinity, we know that the sum to infinity's formula looks like this. It says a over 1 minus r, right? So if it looks like that, you see the variables that we'll have would be a and r. Now here, how can we express this sum that they're referring to? Well, you could say the sum to infinity, this entire section, and if you say minus this part, okay, then you're going to get the sum to infinity from term 3 all the way to infinity. So that's another way we can express it, but we need to find out how do we express this part, because we're going to say the sum to infinity minus the sum of the amount of terms that we have here before the third term. So that is term 1. And then we have term 2, and then that's it. So it's just the sum to infinity minus the sum of 2 terms. Okay, so here's what we're working with. They've given us the sum to infinity minus 2 terms and the sum to infinity itself. We know that this is equal to 1.5 and the sum to infinity itself is equal to 13.5. So this is just going to be a simultaneous equation. Okay, let's go ahead and find the sum to infinity. We know sum to infinity is simply equal to a over 1 minus r. So we'll say this is 13.5 is equal to a over 1 minus r. And I'll just go ahead and make a the subject. So if I want a to be left alone, I need to get rid of this. So we can multiply both hand sides by 1 minus r. And so we have a equals 13.5 times 1 minus r. And now to find the sum to infinity minus the sum of two terms. Well, we would need to understand what the sum of two terms is. This is a geometric series, right? You could write the sum formula, but there's actually an easier way to find the sum of two terms. The sum of two terms, given that we don't know what a is and we don't know what r is, it would be, the first term would simply be a, so t1 is a, and term 2, you can just see this as substituting 2 as an end value into the formula, a multiplied by r raised to the power of n minus 1. So you'd say 2 minus 1, which is 1. And so you see that term 2 is just equal to a multiplied by r. So the sum of two terms is term 1 plus term 2, which is really just a plus a times r. Okay, so the sum of these two terms will equal, so we're just going to take out that common factor of a, and now we have 1 plus r. Okay, so that is the sum of two terms that we have. And now we can just rewrite this. So we're saying that the sum to infinity minus the sum of two terms is equal to 1.5. And we know the sum to infinity is 13.5. And this is minus a times 1 plus r is equal to 1.5. Okay, so now we can just go ahead and transpose this to keep it on one side and bring the number over. So that's 13.5 minus 1.5, which is 12. So this is 12 is equal to positive a times 1 plus r. And then we can make a the subject. Okay, so a can just be the subject in both. So divide both hand sides by 1 plus r. So that is a equals 12 over 1 plus r. Okay, so now that a is the subject of both equations, we can just equate them. So a is equal to a, and we have 13.5 multiplied by 1 minus r is equal to 12 over 1 plus r. Okay, so now we can solve for r. Let's go ahead and cross multiply. So this has a natural denominator of 1, and so we're saying all of this times 1 plus r. Let's first just rewrite it. So it's just 13.5 times 1 minus r and 1 plus r is equal to 12. Okay, now we can get rid of that 13.5 by dividing both hand sides by 13.5, but we're going to rewrite that as well. So this is divided by 13.5, and we'll find out what that is. Now 1 minus r and 1 plus r, this is the product of factorizing difference of two squares. So that is 1 minus r squared is equal to, and let's find out what 12 divided by 13.5 is. Okay, so as a fraction, that's 8 over 9. Okay, so we know it's 8 over 9, and then we can transpose that to make it positive. So if it's over, it's positive, and that's just 1 minus 8 over 9. So therefore, we're saying r squared is equal to 1 minus 8 over 9, that's 9 over 9 minus 8 over 9, which is 1 over 9. And then finally, we can solve for r. So square root both hand sides of the equation, but of course, we'll have to consider the positive or negative solution. But remember that they said specifically r is greater than 0. So we can also just tell them that. Just tell them, but we know that r is greater than 0. Therefore, r is equal to, and we'll take the positive solution, which is 1 over 3. And that is our answer. Okay, and that is the answer to this question. Moving on to the next question. Question 3.2.2, the last question for question 3 says, hence determine the first 3 terms of the series. Okay, so now that we know what r is, let's find the first 3 terms. So we had expressions for a over here and over here. I'll just take this one because it just looks a little more simple. So we'll take this, and in place of r, so we'll substitute that r value. So a is equal to, so this is 12 over 1 plus 1 over 3. And let's find out what that is, which is 9. So that's 9. And now that we know what a is, here's how we can find the first three terms. Okay, so since the first term is 9, to get the next terms, you're really just going to multiply the previous term by the ratio. The ratio was 1 over 3, so we'll say 9 times 1 over 3, and that gives us 3, so it's 9 plus 3 plus, and to get the next term, you'll say 3 times 1 over 3, and that gives us 1, so plus 1, and then that keeps going. So there we go. The first three terms are 9, 3, and 1. And that is it for this question. Question 4 says, in the diagram, a, -2, and 0 is the x-intercept of h of x. And as you can see, they have already completed the p and the q value. The only thing missing is the value of a. And the first question says, calculate a. Okay, now to find this missing variable, we just need to fill in an x and a y value. And we can do that with the points that they have given us. So we're going to go ahead and substitute this point a in place of x and y into our graph. So this is the equation of h. And in place of x and y, we're substituting -2 and 0. So 0 is equal to a over -2 plus 1 plus 2. Okay, so the whole point now is to just get to the a. So to get to this a, we'll say -2 plus 1, which is 1 minus 2, and that's -1. And a divided by -1 is -a. So this a is negative, and we can just transpose it, so it becomes positive. So a is simply equal to 2. And that is our answer. Moving on to the next question. Question 4.2 says, calculate the average gradient of h between x equals -4 and x equals -2. So they've given us two x values, meaning we are finding the average gradient between 2 points. So to find the average gradient, we're simply going to say average gradient is equal to, and we are taking the y2 minus y1 over x2 minus x1. So its y value will be found as a result of substituting an x value. So into this graph of h. So that's h of -4, and we can say minus h of -2. This can, of course, also be h of -2 minus h of -4. Okay, so it will just be the gradient. So we'll put that all over x2 minus x1. And as we can see, x2, we're calling that -4, and minus x1, which is -2. So let's go ahead and find those y values. When we substitute -4 in place of x, given that we know now that a is equal to 2, what do we get? We get 4 over 3. So this is 4 over 3 minus, and then we're going to substitute -2. That's our second x value. And we get 0. So this goes all over, and that is going to be -4 plus 2. -4 plus 2 is -2. So let's just find out what this is. 4 over 3 divided by -2. And our answer is -2 over 3. And that is the average gradient between those 2 points. Moving on to the next question. Question 4.3 says, for which values of x is h of x greater than 4? So we have a hyperbola. In order to find out where h of x is greater than 4, we need to find out where exactly 4 is on the y-axis. So let's go ahead and substitute 4 in place of y here, and let's just find that. So in place of y, we substitute 4, and this is equal to 2 over x plus 1 plus 2. And if you transpose that 2, so you're subtracting 2 from both sides, we'll have 2 is equal to 2 over x plus 1. And then we can just cross multiply at this point. So it's the 2 multiplied by the x plus 1. So 2 times x is 2x. 2 times 1 is positive 2. And then 1 times 2, which is 2. Okay, now you see that we have 2 on both hand sides of the equation. So we can just cancel them. It's like taking the 2 over, and it subtracts and becomes 0. So 2x is equal to 0. And if you divide both hand sides by 2, x is equal to 0. X is equal to 0 only at the y-intercept. So it means that this is a y-intercept of 4. Okay, so meaning on our graph, had there been a y-axis, it would intersect the y-axis at 4. Okay, so It will intersect at 4, and we just need to find out where h of x is greater than 4. So if this is the y-axis, then where is this graph? Where does it have a y value greater than 4? Okay, it has a y value greater than 4 all through here. This is where this has y values that are greater than 4. So we have to tell them for which x values this part of the graph exists. Also notice there is an asymptote here. And let's just establish what that asymptote is. It's the vertical asymptote, right? So with this equation, it is that, let's just write it in its standard form. That is a over x minus p plus q. So the vertical asymptote is that value of p. It's x equals that value of p. But notice that we have an x plus 1 here and not a minus. So if you had to rewrite this so there is a minus, it would be x minus negative 1, meaning p is actually equal to negative 1. And so what this would mean is that we have a vertical asymptote at x equals negative 1. This is going to be important because this graph will not pass the asymptote. So the values of x for which h of x is greater than 4 would be all through here. So all through there, it keeps going closer and closer. So look at the x values that this aligns to. Its values over here. So if we know that this value over here is negative 1 over here, and this value over here is 0 because this is on the y-axis. So it means that the graph of h is greater than 4 for values of x that are greater than negative 1, but less than 0. And that is our answer. Okay, so we can just finally tell them that x is simply greater than negative 1, but less than 0. Of course, you can write this in interval notation, which is x is an element of, and we're going from negative 1 to 0. But notice that negative 1 and 0 are not included x values, so we will use round brackets for them. And that is our answer. Question 4.4 says, determine the equation of the axis of symmetry of h that has a positive gradient. Leave your answer in the form of y is equal to. Okay, so let's just go through a brief explanation on how we find the axis of symmetry of a hyperbola. If we have a hyperbola, regardless of whether a is greater than 0 or a is less than 0, so if the value of a in y equals a over x minus p plus q is greater than 0, then your graph will lie in the first and the third quadrant. And if it's less than 0, it will lie in the second and the fourth quadrant. Now, regardless of that, let's just draw a graph that lies in the first and the third quadrant. Regardless of that, it will have two axes of symmetry. Remember, an axis of symmetry is just a line that splits the graph into two equal halves. So they form a mirror image of each other. Okay, so the axis of symmetry of a hyperbola, we have two. One with a positive gradient, okay, so it's increasing, and one with a negative gradient. So that one will be decreasing. The one with a positive gradient is y equals, now it's easy to remember the one with a positive gradient because it just follows this flow. You see how we have x minus p plus q. That's exactly what it is. It is x minus p plus q. So if you remember the general form of your hyperbola, you will always remember this information. Okay, and then the one with a negative gradient simply looks like this. It's y equals, okay, we also have an x minus p plus q, but what happens is we have a negative in front of x minus p. And so when that distributes in, it becomes negative x plus p plus q. Okay, and that's what it looks like. So they specifically want the one with a positive gradient. So the axis of symmetry with a positive gradient would look like this. So all we need is the value of p and the value of q. So we can see the value of p and q in our hyperbola. P, we found that p is actually negative 1 because this is x minus negative 1, okay, x minus p. And q is just plus q. So whatever this is, that is q. So we can see p is negative 1 and q is positive 2. Therefore, our axis of symmetry is y equals x minus p, so minus negative 1, plus q, so plus 2. So this is y is equal to x plus 1 plus 2, which just gives you plus 3. And that is our equation. Question 4.5 says, write down the equations of the asymptotes of g if g is the reflection of h over the x-axis. Okay, let us look at what happens when we reflect a point or a line over the x-axis. Say we have a point over here, and let's call it 1 and 2. If you reflect this point over the x-axis, it means it will appear here. So what you notice changed about this point? This point had a y value at 2 and an x value at 1. Well, the x value is still exactly the same. It's still 1. But do you notice now that the y value has changed? Remember that a reflection through an axis just means that this graph just appears on the other side of that axis, but it's still at the same distance away from the x-axis as it was. So if it was 2 units away from the x-axis, it will also be 2 units away from the x-axis, making this -2. So do you see now that a reflection across the x-axis causes the y values to change? And really, the y values just get multiplied by -1. Okay, let's see how this will affect our asymptotes. We know that our asymptotes are x equals -1, since that p value is -1. And the other asymptote, so this is the vertical asymptote, the horizontal asymptote was y equals 2. We already saw that from the previous question with p and q. So since you know that all the y values of this graph would change, which asymptote would change? It would be an asymptote with a y value, which is the horizontal asymptote. So this one stays exactly the same. Remember, this is the graph of h of x. That's what their asymptotes look like. But the graph of g of x asymptotes will look like this. X is still going to be equal to -1, but this time now, y will change to -2. And that is our answer. And that is it for question 4. Question 5 says, sketched below is f of x, which is equal to -12x squared plus 1/2x plus k, and h of x, which we can see is an exponential function, is q to the power of x. The x-intercepts of f are b and c. H and f intersect the y-axis at d. Okay, so there's a missing y-axis over here, so it just connects like that. So they intersect at D, as we can see there. And then they tell us that A is a point on H vertically above C. So this is vertically above C. So they share the same specific coordinate. It could be X or Y. You need to remember that. And they say with a Y value of 1/4. We should probably put that down. So this has a y value of 1/4, meaning it's currently just x and 1/4. Let's just keep that like that. And then they tell us that PR is perpendicular to the x-axis, as we can see. Let me also just extend that line. And the first question is, calculate the coordinates of D. So where is D? D is specifically the y-intercept of the graph of H and F. So do you see that F is not complete? K is missing. Okay, so we can't really look at that y-intercept from there. So we're going to have to rely on H. So H, you can still find it because of the way it has been written. H of x is simply just q to the power of x. To find the y-intercept, you need to make x equal to 0. So that's what we're going to do. We'll say h of 0 is equal to q to the power of 0. And anything to the power of 0 is equal to 1. So that is D. D, the coordinates of D are 0 and 1. That is our y-intercept. Moving on to the next question. The second question, 5.2, is to write down the value of k. So we saw how k is also the y-intercept. Okay, it's the y-intercept of this graph of f because it has been put in its standard form. So that is the y-intercept. So the value of k is also equal to 1. So k equals 1. Moving on to the next question. Question 5.3 says, calculate the length of BC. Okay, so what is the length of BC? Let's look at BC. Okay, B and C are x-intercepts of the graph of F. So we would just have to find the x-intercept of this graph. Let's just ensure that we fill in what k is as 1. Okay, so this is the graph of f. And to find the x-intercepts, we simply make y equal to 0. So we'll say 0 is equal to negative a half x squared plus a half x plus 1. So we can say that there is a common factor all through of negative a half. So we can divide both hand sides by negative a half, or you can choose to just multiply both hand sides by negative 2, okay? Because negative 2 over 1 would be the reciprocal of this, and it will cancel that negative 1 and the 2. And what we do on the one side, you must do on the other side. So we're multiplying both hand sides by negative 2. Okay, so this now becomes, when it multiplies in, that becomes x squared. When that multiplies, that becomes negative x, and that becomes minus 2 is equal to 0. And let's factorize. So what times what gives us x squared? That is x times x. And what times what gives us 2? It's 2 times 1. But this is negative, so one of them should be negative. Which should be negative so that we can ensure that the middle stays negative. You should make the bigger factor negative. So negative 2 plus 1 equals negative 1. So that's that coefficient there. So therefore, this means that x is equal to positive 2 or x is equal to negative 1. And now we can just look at which ones would be b and c. This is the negative, so that is negative 1, and that is positive 2. That is great, and that really helps us a lot with a. Okay, so we can just tell them what b and c are. So the coordinates of b are negative 1 and 0, and c is 2 and 0. And so to find the length of BC, seeing that this is a vertical line, all you have to do is count that distance. You can decide to count it like this and say, oh, that's 2 units, okay, to the right, and that's 1 unit, and that's therefore 3 units in total. Or you could just say the higher x value minus the lower x value. So we can say that BC is simply equal to 2 minus negative 1, which is equal to 3. And that is our answer. Question 5.4 says, calculate the length of PR if OP is 2 units. Okay, let's look at that. So they want us to find PR if OP is 2 units. Okay, telling us that OP is 2 units, how does that help us? OP is 2 units, meaning from the origin to P, we just go 2 units to the left. And that would make this x value negative 2. And how does that help us find PR? Well, do you see that if this is negative 2, P and R are vertically in line with each other. R is a point vertically below P. So that means they have the exact same x value. So it means that this point over here, its x value is negative 2, and we would just have to find its y value. And once we find its y value, that would tell us exactly the length of PR, because it's going from 0 to whatever that y value of that point is. Okay, so we got the x value. We can take that and substitute it into the graph that it is on. It's on the graph of f. So let's substitute it into f. So we're going to find out what f of negative 2 is. Okay, so this is the graph of f. So we'll say f of negative 2 equals negative 1 over 2, negative 2 all squared, plus 1 over 2, negative 2, plus 1. And let's find out what f of negative 2 is. And this is negative 2. Okay, so if it is negative 2, that is the y value of that point. Okay, so now we know that this y value is actually negative 2. So if this is negative 2, what is the length of PR? PR is simply, because it's 0 to negative 2, it's 2 units. Okay, so there we go. We can finally tell them that PR is therefore 2 units. PR equals 2 units. And that is our answer. Question 5.5 says, consider h of x is equal to q to the power of x. 5.5.1 says, calculate the value of q. Okay, so how do we find that value of q? Well, in order to find that value of q, we would need 1 point, because we need something to fill in place of y, and in place of x. So do we have a point on this graph of h? Looking at the graph of h, we have the y-intercept, but do you see, because this y-intercept, yes, it was 1, but it's 1 and 0. So here's the thing about that. It's not going to be very helpful, because if you say the y value is 1 and the x value is 0, well, you just get 1 equals 1. So it doesn't help you find q. Okay, so look at what we can use. We can use this point A. It's vertically above C. So since it is vertically above C, it means that they share the same x value. See, that x value is 2. This x value will also be 2. They only have a different y value. This has a y value of 1 over 4. This has a y value of 0. So in order to find q, we can just substitute this point A on the graph. Now that we'll know that A is actually 2 and 1 over 4. So let's go ahead and tell them that A first is 2 and 1 over 4, and then we'll substitute it into the equation of h. So in place of y, we say 1 over 4 is equal to, and we say q to the power of 2. And this is our equation. So we're trying to solve for q. How do we get to q? There's a squared, so we need to get rid of that squared by square rooting both hand sides. So since we have a squared, we can square root both hand sides of the equation. Yes, there is a positive and negative solution for the equation, yes, but not relevant to q. You see, the thing about q is a base. It's the base of an exponential function. For it to actually be exponential, the base has to be greater than 0. Q has to be greater than 0. If q is a negative number, that's not going to be an exponential function. That graph is going to basically oscillate between positive and negative y values. It's going to be positive one time, negative another time, positive one time, negative another time. And then it just creates some sort of a zigzag pattern, and it's not an exponential function. Okay, so that means that q is therefore equal to 1 over 2. And that is our answer. Question 5.5.2 says, hence determine the equation of the inverse of h in the form of y equals. Okay, so we know now that the graph of h is y equals a half to the power of x, because we found out what q was. Okay, so let's just write it as y equals. And so to find the inverse, we first swap the x and y value. So now this is x equals a half raised to the power of y. And to make y the subject, we're going to use log. So we'll just say y is finally equal to log, and our base is 1 over 2, and then we'll put x. And that is our answer. Moving on to the next question. Question 5.6 says, write down the range of h. Okay, so if this is the graph of h, what is its range? The range is all the possible y values of this graph. So focusing on that graph of h and all the y values that it has, do you notice how it does not have any y values? Here, below the x-axis, there are no y values. And this is because this graph of h has an asymptote. Now, right now it's not visible, but the graph of h's asymptote, looking at the equation of h, remember that that graph is actually naturally in the form of y equals an exponential function, right? It's y equals a multiplied by a base raised to the power of exponents, and then there could be a shift, horizontal shift, and then there is plus q. Now, the horizontal asymptote is that horizontal line that the graph will never touch. And right now, we don't see anything by h. There's no plus q at the end. Not talking about this q though. Okay, so because of that, it means that that q value is 0. That horizontal asymptote is 0, meaning it will never cross this line. So it doesn't have any y values below the x-axis, meaning its y values are values that are greater than 0. Okay, those y values that are all greater than 0. That's where it has y values. So for the range of this graph, we can simply say that y is greater than 0. And that is our answer. Okay, so you can either write it like this or like that. And that is our answer. Moving on to the next question. Question 5.7 says, determine the equation of g, the tangent to f at b. Okay, so it's a tangent to f at b. a tangent is still a straight line. So it's in the form of y equals mx plus c. So this means that the next thing we'll need to do is find the gradient. And then, of course, we need that y-intercept. But we'll just need 1 point on that tangent to find its y-intercept. So let's go ahead and see how can we find that gradient if the tangent is at B. So this is B. It means that that tangent line goes something like this. It's going to B and then it just, crosses. It does not really intersect like that. It just touches B only on the graph of F. So how do we find its gradient? How do we find the gradient of this line? Well, it passes through B and B is on the parabola. So if we could find the gradient of the parabola, then find out what exactly is the gradient of the parabola at this point B, then we have found the gradient of the tangent. So how do we find the gradient of a parabola? You find the gradient of a parabola by deriving the parabola's equation. Okay, so I just got the parabola's equation. This is what it looks like, and we're going to derive this function. So this is f of x, and we'll find f prime of x, and that will find the general gradient of the parabola. Okay, so that is negative 1 over 2 times 2, which is negative x. Exponent minus 1 is 1, and you don't have to rewrite it. Then we have 1 over 2 times the exponent of 1, which is plus 1 over 2. And you will say exponent minus 1, but that's 0, and anything to the power of 0 is 1. That multiplies to a half to stay a half. So this is the general gradient of the parabola. Now we specifically want that gradient at that point B. Knowing that B is negative 1 and 0. So we're specifically trying to find the gradient of the parabola at the point where x is equal to negative 1. So we'll say f prime of negative 1, and this will tell us that gradient. So negative 1 plus a half. Okay, so that's going to become positive, and 1 plus a half is 3 over 2, or 1.5. So the gradient of that tangent is 3 over 2. Great, we just found its gradient, and now we need to find the y-intercept. We can find the y-intercept by substituting a point on the tangent. The only points that we have on that tangent is B, okay? It's the only point over there. So let's go ahead and substitute that point B, and then we'll have our equation. You can choose to use y equals mx plus c, or you can use this. So y minus y1 is equal to m times x minus x1. And in place of x1 and y1, we substitute negative 1 and 0. So we'll say y minus 0 is equal to our gradient of 3 over 2 times x minus negative 1, which becomes plus 1. Y minus 0 is just y, and then we distribute. So this is 3 over 2x and plus 3 over 2. Okay, did they tell us to put it in any format? Not really. They just said of g. So let's go ahead and just call this g of x. So this is g of x equals 3 over 2x plus 3 over 2. And that is the equation of our tangent. Moving on to the next question. Question 5.8 says, for which values of x is x multiplied by f prime of x less than 0? Okay, so we can think about what the graph of f prime of x will look like. And honestly, for this one, we don't really need this part so much. Okay, but the graph of f prime of x, because f of x is a concave down parabola, if you derive this, it will give you a straight line with a negative gradient, meaning that that graph is going to move down like that. Okay, so we already have the equation of the derivative. So in this case, it actually makes it a little more simple than, it would have been had they not told us to derive this. So there's that graph of f prime of x. Okay, it's a decreasing function that we have over there. And we just need to look for specific things. So here's the thing about it. This is why I said we don't really need that actual graph. So let's look at the possibilities of that. If x is a positive value and you multiply it by the y value of f prime of x, and that is a negative value, then you will get a negative answer. That is that value less than 0. Less than 0 just means negative. Okay, another criteria we can look for is where the x values are negative and at the same time the y values of the derivative are positive, then it's going to give us a negative value. So here's what we're looking at. We're going to have that graph, and it's a decreasing function, but we will need one specific point on this graph. You see, to find out whether the graph of f prime of x has a positive or negative y value, you need to find out where it is equal to 0. So say it was equal to 0 here and it just looked like this. It's going to look like this anyway, so we're going to use this graph. It's going to slope downwards. You see that for all these values over here, it has positive y values. See, positive y values all through here. If you line these points, these individual points to the y-axis, they all have positive y values. And if you line these ones to the y-axis, they all have negative y values. This is why the x-intercept of the derivative of f is going to be very important here. So let's find that first. We already had the graph of f prime of x, so let's just find its x-intercept. Okay, so the x-intercept is where y is equal to 0. So we're going to say 0 is equal to negative x plus a half, and then just transpose the negative x. So x is equal to a half. So now that we know that it's a half, this helps us a lot. So we're just going to look for whether graphs meet this criteria. So first, we're looking for where the x values are positive, and at the same time, the y values of f prime of x are negative. Okay, this is f prime of x. So where do we first have positive x values? Positive x values on the x-axis, they're just all through here. Now for these same positive x values, the graph of f prime of x must have negative y values, meaning it needs to have negative y values. Okay, so that is this section over here. And you see that the graph exists in this category over here. Okay, so now we just have to tell them for which values of x this happens. If you line these points up to the x-axis, you see that this is specifically where x is greater than a half. These are values that are going towards the right-hand side of a half. Okay, so we got that one. We were able to find that criteria. The second criteria we're looking at is where x has negative values and the y has positive values. Okay, so x must be negative while y is positive. Do we have the graph of f prime that exists in this region? Yes, we do. It's over here. Okay, so we're going to say it's all of this over here. So where does that start? You cannot take this part, okay, because this is the section where x is positive and y is positive. That's not what we're looking for. But this part works. So this starts at the y-axis where x is equal to 0, but not exactly at the y-axis because they didn't say less than or equal to 0. They said it must just be less than 0. If you took that x value of 0 here times the y value, the positive y value it has, it will give you 0. Okay, so we're not including the actual x value of 0. So if you line this down to the x-axis, do you see that the x values for which this exists is values that are less than 0, because this is 0 and then its value is less than 0. Okay, so this exists for values of x where x is less than 0. They are not related. We don't have to write them together. And this is our answer. And that is it for question 5. Question 6.1 says, Jane deposits X Rand into an investment account. How long will it take for the value of the investment to double if the interest rate is 5.4% per annum compounded annually? So money is being invested and we want to find out how long it takes to double, to grow. So this is compounded annually, meaning we're working with compound interest growth. So the formula is A equals P times 1 plus I raised to the power of n. Now looking at the value of A, they said that this money is first X Rand, it gets deposited. So P, this is the starting amount, okay? P is X. And the money must double. So if we started off with X, double of X is 2X. So we're going to say 2X is equal to P is X, and we're saying 1 plus, and the interest rate is 5.4%. So we'll say 0.054, and this is compounded annually, so we're not going to divide by anything. So raised to the power of n, because the question is how long. Okay, so this is an exponential equation at this point because we're trying to solve for n. And in order to get closer to the n, you see that we need to get rid of the x. So we can divide both hand sides by x. It is safe to divide by x here because x is definitely not equal to 1. Money was invested, and for it to double, there was money. So this would cancel, and we have 1 plus 0.054 to the power of n, and this is equal to 2 when they cancel. So we're just trying to solve for n. You can actually just add these together just to see if it gives a fraction. So 0.054. Okay, it does. Not a nice looking fraction, but it's fine. 527 over 500. Okay, so raised to the power of n. And now to solve for n, to make an exponent the subject, we'll say n is equal to log, and our base is 527 over 500, and the answer was 2. So let's go ahead and find out what this is. So now calculator will say log, and our base is 527 over 500, and then we'll put 2 there. Okay, so let's see. N is equal to 13.179. Okay, now here's the thing about this. If we leave it at 13, that money is not going to double. It hasn't doubled yet at 13 years because there's still this remaining 0.179 to go. So as long as this is not applied, it's not done. So you can just leave it as n equals and just round off to 2 decimal places, because at that point it would have already doubled. And if you want to double check, you can actually just substitute this into your equation, okay, in place of n. But of course you would have to use one number. So you're going to have to try to use like maybe something like 100. And then if it doubles and actually becomes 200, then you know it's fine. So this is just 13.18. And that is our answer. Okay, so this is the amount of years it will take. And moving on to the next question. Question 6.2 says, Tabo starts a printing company and needs to borrow money for startup costs. He can make equal monthly payments of 3,300. Okay, so equal monthly payments, meaning this is X. And also notice they're talking about payments, so this is probably concerning a loan. And then they say, what amount can Tabo borrow if the interest rate on the loan, okay, is 12% per annum compounded monthly, and the loan is granted over 5 years. Okay, you see in this question, they're moving backwards. You know how in a loan, right, you get money at first, you borrow the money, and then you pay it back over time. In this question, they have not told us the amount he's going to borrow. They want us to find out how much he needs to borrow. So you'll be able to see this by looking at your present value formula. So present value is equal to x, and then 1 minus 1 plus I raised to the power of negative n over I. And looking at what these values specifically mean, the present value, that is the loan amount. That is the amount that is owed depending on the time period you're at. So clearly, in this question, they're asking us, what amount can Tabo borrow if the interest rate is this? So this is what they're asking for, the present value. So find out what his loan amount must be. If they have told us that X is 3,300, they told us the interest, and they told us that this loan goes over for 5 years. We're looking for the amount he must borrow, the loan. So it's equal to 3,300, and we say 1 minus 1 plus, and the interest is 12% compounded monthly, so 0.12 over 12 raised to the power of negative. Now remember, this loan goes for 5 years. So N in present value, it always stands for the amount of payments you still have to make. So we're saying 5 times 12, okay, because it's 5 years, but it's compounded monthly. So he's going to pay this every month. So it's a total of 60 months, which means at this point that we are at, he has 60 months left to pay off That makes perfect sense because we are only at the beginning of his loan. We're trying to find out how much he needs to borrow. Okay, in other words, how much he owns at the beginning when nothing is paid. And so over 0.12 over 12. And let's find out what this gives us. So the present value, that is 60. Okay, so the present value is 148,351.61 cents. Okay, that's the total amount that he needs to borrow. Okay, and that is our answer. Moving on to the next question. Question 6.3 says, a group of investors consider investing in a fund that promises growth at a rate of 5% per annum compounded quarterly. Calculate the effective annual percentage rate of the growth promised. So they're speaking about an interest rate that is compounded quarterly, and they want us to tell them the effective annual rate. So this is nominal and effective interest rate. Okay, so with nominal and effective, the formula looks like this. We say 1 plus I effective, the interest of the effective, is equal to, now they usually say to the power of 1 because this is a yearly interest. Okay, it's a yearly interest rate, but you can put it there. It doesn't have to be there because to the power of 1 stays the same. And then we say 1 plus I nominal over n raised to the power of n. And so this would be the amounts that was quoted, okay, that is not in a year. Here's the thing about nominal and effective interest rate. Nominal interest rate is what the bank would quote you, or whatever the agreement quotes you. This will be compounded monthly or quarterly. But then the thing about it is that with interest builds on interest. So what they quote you per month is not necessarily the interest that it would amount to in a year. And so that's the reason we look at nominal and effective interest rate. This is that monthly or that quarterly interest rate that is quoted, and then the effective is going to tell you the interest rate that you actually received in that year. Okay, so that's just the backstory on it. And we just need to substitute into the right places. So the effective, that is the per annum interest, the per year. So we're trying to find that, and they quoted 5% compounded quarterly. So here's how we put this in. We're saying 1 plus I effective because that's what we're looking for. And we're saying 1 plus the interest quoted was 5%, which is 0.05 over, now it's compounded quarterly. So we'll divide by 4 and raise to the power of 4. The whole point is to find I effective. So we'll say I effective equals and rewrite this. And then we can transpose that 1. So it's minus 1. Okay, let's put this on the calculator and see the effective interest rate. And here's what we get. Okay, so as a decimal, it's just 0.05094, but you still have to multiply this by 100 so that we can look at this as a rate. So I effective is equal to, and you're just going to take that answer and times 100. Okay, so the actual annual interest is 5.09%. Okay, so you see how it is more than the one quoted because interest builds on interest. And that is our answer. Moving on to the next question. Question 6.4 says, Sarah is 18 years old and wishes to accumulate 10 million rand by the month before her 50th birthday. Okay, so this is from when she's 18 to 50. She will deposit equal monthly payments into an account that pays 5% per annum compounded monthly. Okay, the first payment starts on her 18th birthday and the last payment 1 month before her 50th birthday. Okay, but it's a payment though, so keep that in mind. Calculate the monthly installment that Sarah will make. So they want us to calculate the monthly installment that she's going to make. So in this situation, Sarah is saving money every month and wants to reach 10 million. So this is a case of future value. So let's look at this timeline first. So from her 18th birthday, when she's 18 here, she starts making these deposits and she will stop a month before her 50th birthday. So let's look at from when she is 18 to, since we need to end at 50, let's just look at till when she's 49 just to see what happens here, right? She's making payments on all of these days. So the main goal, it seems like they've given everything. They've given the future value itself, it's 10 million, and we have to find X. And the only thing that we need to look for now is that value of N. So in future value, N specifically stands for the amount of payments that are made. So let's see. Now, the reason I'm looking at 49 here is because she doesn't make the payment on her 50th birthday. But this does not seem like it's going to matter because she still makes it a month before her 50th birthday. So every month she's going to make a payment, okay? When she's 18, she would have made all those months payment. When she was 19, she's going to make all those months payment, and so on. Now, with this one, she's still going to make all the months payment, and the last payment is 1 month before her 50th birthday, okay? So let's just say she was born in January, just to make sense of this. So if she was born in January, then that means that she's going to make, when she turns 18, she makes a payment, and then she's going to make a payment for 12 months. And then when she's 19, this is a new year, okay? So from 18, right, from January to December, she has made payments. And so that will be a total of 12 payments from January to December. And then when she's 19, this is a new payment cycle starting for her new age. So it's going to be from January again all the way to December, again giving you 12 months. And then when she is now 20, she starts a new cycle of payment. So this will continue, and let's look at how it continues till 49. So before she's 49, okay, she'll be 48. So what happens there is when she turns 48, she makes a payment in January again, all the way to December, right? Makes a payment. Then when she's 49, this is what happens. Okay, so that would still be making payments for 12 months. When she is 49, she's going to make a payment until 1 month before her birthday, meaning she's making a payment from January to a month before her birthday. Her birthday is in January, so she's making a payment to December. So that is still 12 months. So we don't have to, subtract a month because it's all going to be 12 months. Okay, so the total payment, N, will be found by saying 50 minus 18, which is 32. And now we can find this X value, the monthly installments. So we'll put the future value formula down. Future value is equal to X multiplied by 1 plus I raised to the power of positive N minus 1 all over I. And so the total amount she's trying to get is 10 million. Okay, and this is equal to, we're trying to find X, and we are putting down our values here. So this is 1 plus, the interest is 15% compounded monthly. So this is 0.15 over 12 raised to the power of, now we know that the total years, there are 32 years of payment. So it's going to be 32 times 12 and then minus 1 all over and the interest. Okay, so with this type, it's a type where we can easily find the value of X because X is just a value being multiplied by all of this. So if we need to get closer to the X, we need to divide by this number. So we'll say this entire number, divide both sides by it, and we're really just saying X is equal to 10 million divided by all of this. Okay, so it will look like this. So finally, X is equal to, and when we put that into the calculator, you're going to get 1,068 Rand, and that 6 is going to round the 4 up to a 5, so 0.85 cents. That is the amount that she has to save every month in order to accumulate this to 10 million rands. And that is our answer, and that is the final question for question 6. Question 7.1 says, given f of x is equal to negative 2x squared plus 1, we need to determine f prime of x from first principles. So from first principle, so we'll need the second y value. So that is f of x plus h. So in place of x, we'll substitute x plus h. So this is negative 2 times x plus h all squared plus 1. And if we distribute this part, we have negative 2 times. We'll square the first term, which is x squared, square the last term, which is positive h squared, and then first term times second term is xh, but then we multiply that by 2. So that's positive 2xh. And then we'll say plus 1. Now we can distribute that negative 2 in. So that is negative 2x squared minus 4xh minus 2h squared plus 1. Okay, and now deriving this from first principles, we'll use this formula. F prime of x is equal to the limit as h approaches 0. And we're saying f of x plus h, which we just found, minus f of x all over h. Okay, so in place of f of x plus h, we substitute what we have just found. But of course, you still have to say the limit as h approaches 0. So substitute, and we're saying minus f of x. F of x has two terms, so make sure you protect this with brackets. We're saying minus, and we're subtracting by negative 2x squared plus 1. So negative 2x squared plus 1, and this goes all over h. And this is equal to the limit as h approaches 0. And we're saying rewrite what we had already, and you're just going to distribute that in. So when it multiplies in, it becomes positive 2x squared and minus 1 all over h. And now we have terms cancelling. So what will cancel is whatever you were subtracting by. So this cancels with a negative 1, and this one will also cancel with the positive 1. And now we have is equal to the limit as h approaches 0, and we have negative 4xh minus 2h squared all over h. And now we can finally solve the problem that we had initially. The whole problem with this is that there was an h in the denominator, so we couldn't find the limit as h approaches 0 by substituting 0. So we're going to take it out as a common factor, and now we have negative 4x and minus 2h all over h. So the h's cancel, and we are left with this. Now at this point, you can choose to just write this or substitute. So I'm just going to write it one more time. And now finally, f prime of x is equal to negative 4x, and in place of h, we're going to substitute 0. So f prime of x is finally equal to negative 4x, and that is our answer. Moving on to the next question. Question 7.2, 7.2.1 says we need to determine f prime of x if f of x is equal to 1 over 2x squared minus 5 over x. So with the way this looks right now, why can we not derive this? Well, you'll notice that we have an x in the denominator. The first term is fine. This is ready to be derived. So we're just going to fix that first and then get to deriving. So this is 1 over 2x squared, and this is minus 5. Now the x is in the denominator, so we need to move it up to the numerator. Now we'll bring it up, but it means that the exponent will now become negative. So it had an invisible exponent of 1, now it has negative 1. And now we are ready to derive. So f prime of x is equal to, we'll say the coefficient times exponent, a half multiplied by 2 is 1. So the x stays, and there's a 1 in front, and so exponent minus 1 is 1, and you don't have to rewrite that. Then coefficient times exponent, and that gives us positive 5. And then x to the power of exponent minus 1, and that's negative 2. Okay, and this is our answer. You can either choose to leave it like this, or you can, of course, choose to write it as a positive exponent. So that would be f prime of x is equal to x plus 5. Now, because this exponent is negative and it's currently in the numerator, it will move down to the denominator. So over x to the power of positive 2. And that is what that would look like. So you can leave it like this or like this, and that is perfectly fine. And that is our answer. And then 7.2.2 says we need to find the derivative of this function. So let's see what is wrong with it right now. Can we derive? Not yet. So we have an x in the denominator, but we also have a third with x. Now, please note that if you have a third that is a number, this is perfectly fine. There's nothing wrong with this. But it becomes a problem when x is under that radical. So we need to fix that first. So we'll keep writing dx. And now we have negative 2x squared. So we're going to write this as a base to the power of a rational exponent. So this is plus x raised to the power of. So do you see that? The inside exponent, which we cannot see, the exponent on x is a 1. To rewrite this, we'll write this as the base, and then you say the inside exponent over the outside exponent. Okay, so that's fine. Over, and we have x to the power of 2. Okay, now it's not actually done at this point. So this is still in the denominator, and what we can do to resolve this is, you see that in the numerator, we are adding these values. So we can just split them. We can call this negative 2x squared over x squared and plus x to the power of 1 over 4 over x to the power of 2. And now they're just going to divide. We're not moving this to the numerator. It's not necessary. So we're saying dx, and we have negative 2. And now you have x squared divided by x squared, which becomes just negative 2. And here, remember when dividing, your exponents get subtracted. So we're saying the top exponent minus the bottom exponent. What is 1 over 4 minus 2? So we could rewrite 2 as negative 8 over 4. So that is 1 minus 8, which is negative 7 over 4. So this is plus x to the power of negative 7 over 4. And this is what we have to derive. So when we derive this, it's simply equal to, when you derive a constant, it is 0. And when we derive this, we'll say the coefficient, the invisible one, times this negative 7 over 4 is negative 7 over 4. And then we still have x, then exponent minus 1. If you say negative 7 over 4 minus 1, you can say minus 1 in the form of 4 over 4. So that's going to just be negative 11 over 4. And that is our answer. And that is it for question 7. Question 8 says, in the diagram, the graph of f of x is equal to negative x cubed plus 5x squared plus 8x minus 12 is drawn. A, B, and C are the x-intercepts of f. E is the turning point of f. T is a point on f, and G is a point on the x-axis such that TG is perpendicular to the x-axis. Okay, that's a fancy way of saying that T is vertically above G, meaning they share a specific coordinate. And lastly, they tell us that D is the y-intercept of f. Okay, so the y-axis has also been left out here. We'll just have to draw it, ensuring that it passes D. Okay, so that is D over there. And the first question is to calculate the coordinates of C if B is 1 and 0. So C is one of the x-intercepts. And to find that, we would naturally have to make y equal to 0, because at the x-intercept, y is equal to 0. So we have the equation of f, and we can make y equals to 0, but then we would have to factorize. So that's probably why they gave us b, to tell us that, hey, we've given you a factor, so you don't have to search for it. Okay, so this is our graph of f. Let's just rewrite it. Okay, so we're just going to make y equal to 0. Now that we have this, using the long division method, we're going to take the coefficient of each of these terms. So here, the coefficient of x cubed is negative 1, and then we have positive 5, positive 8, and negative 12. And around these, we're going to draw an L backwards. Now, the number that goes here is that value that when substituted into your equation, it gives you 0. And we already know what this value is. We don't have to search for it. Naturally, you would have to take the factors of negative 12 and you would have to substitute and substitute just to find where it gives you 0. But we don't have to do that anymore because they have given us b. They told us that b is 1 and 0. The y value is 0, meaning when you substitute x, it gives you 0. So the number that goes here is 1, and we know that. Okay, and now let's find the factors. So we drag -1 down, and then we say -1 times 1, and then that gives us -1. So -1 plus 5, because this is positive, and that gives us positive 4. 4 times 1 is 4, and then 4 plus 8 is 12. And then 12 times 1 is 12, and 12 minus 1 is 0, and we end at 0, so we know that this is correct. Okay, so this is what we have. You see these numbers here, these coefficients, they are the coefficients of our quadratic expression that this factorizes to. So this is x squared, this is for the x, and this is for the constant. So here is how we will write our factors when factorizing this. So that would mean that since x equals 1, since 1 is one of the numbers that works, it just means that x is equal to 1 is one of the solutions we will have. So the factor that it will be would be x minus 1. See, if you say x minus 1 equals 0 and you transpose the -1, you get x equals 1. And then the other factors come from here. So we're going to say negative and the variables is x squared, and then plus 4x and plus 12 is equal to 0. Okay, so we're just factorizing this. And now all we have to do is factorize this part. So here we will say x is equal to 1, which we already have, or negative x squared plus 4x plus 12 equals 0. And let's factorize this. So it has a common factor of -1, so we can just multiply both hand sides by -1. And so this is x squared minus 4x minus 12 equals 0. Open up two brackets, equated to 0, and we're saying what times what gives us x squared? It's x times x, and what times what gives us -12, but can give us a -4 in the middle. We can try 6 and 2. So if we make the 6 negative, then 6 plus 2 is -4, okay? And they still multiply to -12. So this means that the other solutions we have are x equals +6 or x equals -2. And now we will just have to decide on which one is C that they asked us for. Okay, so C is way over here. So it's the positive, and it's the biggest positive one that we have. So that is 6. So C is 6, and we now know that. And so that would mean that A is -2. Okay, so that's -2. We'll just keep that in mind. So let's just finally conclude that this means that C, the coordinates of C are 6 and 0. And that is our answer. Question 8.2 says, determine the coordinates of E. So as we can see, E is one of the turning points. Okay, so the one with the positive x value. So to find the turning point, remember that this is the point where the gradient of this function is equal to 0. So that's what we're going to use. So let's go ahead and find the gradient of our function. We'll rewrite our function first, and we'll find the gradient of this function. To find the gradient of a function, you derive it. Okay, so we're saying f prime of x, but we're specifically looking for where the gradient is equal to 0. So we'll make it equal to 0. So deriving this function, coefficient times exponents, that's -3x squared, exponent minus 1, that's why it's a squared, and then coefficient times exponents is positive 10x, and that becomes a plus 8, and the x falls away, is equal to 0. Okay, so now that we have this, we can factorize it, but this is negative, so let's just multiply both hand sides by -1 to make it positive. So we have positive 3x squared minus 10x minus 8 equals 0. Okay, so what times what gives us 3x squared? That's 3x times x. And what times what can give us 8? Well, you could try 4 and 2 or 8 and 1. And let's just see which ones will help to form -10 in the middle. So let's say we tried 4 and 2. Okay, I can already see it would rather work like this. We could use 12 and 2. So it will form 12 if you put the 4 here and you put the 2 here. So that is 12x when you cross multiply 3x times 4, and x times 2 is 2x. And you see that if this stays negative 12 and this stays positive 2, then negative 12x plus 2x is negative 10x. So here, how do we get the 12x? We got it by saying 3x times 4. So we're going to give the negative to the 4 and the positive to the 2. So there we go. Our factors are 3x plus 2 and x minus 4 is equal to 0. And so therefore, to solve for x, we say 3x plus 2 equals 0. So 3x is equal to negative 2 when you transpose. And if you divide both hand sides by 3, x is simply equal to negative 2 over 3. Or here, x is equal to 4. And those are our answers. Now we need to find which one specifically belongs to E. So remember that E was on the positive part, right? So this is what we're going to take for E. So let's find the y value belonging to this x value. We can find that by taking this x value and substituting it into the original function. So this is our original and we'll substitute it. So we're saying x is equal to 4 here. So we'll say f of, and in place of x, we say 4 equals negative 4 all cubed plus 5 times 4 all squared plus 8 times 4 minus 12. And let's find out what f of 4 is. And so that is 36. Okay, so we know that this is 36 now. Therefore, it means that the coordinates of E are 4 and 36. And that is our answer. You can also fill it in your diagram. Moving on to the next question. Question 8.3 says, for which values of x will f be concave up? Okay, so you see that you have two types of curvature or concavity on our graphs. So concave up and concave down. They want to find out the values of x for which it will be concave up. Now the points where the graph changes from being concave up to concave down is here at the point of inflection. So we could find that, or we could just deal with this the algebraic method, which is like this. To find out where the graph will be concave up, you can simply say this is where the second derivative is greater than 0. Okay, so let's go ahead and do that. We already have f prime of x, so we can start from there. Take f prime of x and then derive it further to get the second derivative. So if that is f prime of x, then the second derivative would be coefficient times exponent, that is negative 6x, and then plus 10, and of course that x will fall away. So this should just be greater than 0. This is a linear inequality, so just solve for x. So you can leave negative 6x here and say greater than and transpose, so that's negative 10. Then we'd have to divide both hand sides by negative 6. So what happens when you multiply or divide by a negative with inequalities? The sign will change direction, so it now looks like that. So therefore, x is less than negative 10 over negative 6. They both have a common factor of 2. So divided by 2 is 5 and divided by 2 is 3. So x is simply less than 5 over 3. And that is our answer. Question 8.4 says, calculate the length of OG if the tangent to the curve at T is parallel to the tangent to the curve at D. Okay, so let's look at this, and I'm just pinning this to the screen, and let's see what they mean by this. So the main goal is to find the length of OG. So we need to find the length of this line. And you see that in order to find the length of that line, you just need to know what that x value of G is. And to find the x value of G, you need to know the x value of T, since they are vertically in line, meaning they share the same x value. Okay, so they told us that the only information they gave us about this is that we have a tangent to the curve at T. But that tangent is parallel to the tangent to the curve at D. And we would have to find the length of OG. So what is that x value? Okay, that is a very interesting way, a very nice way actually, for them to give us information to find this x value at T. Telling us that these tangents to T and D have the same gradient will help us to find out exactly what that gradient is. So if we're able to find out what the gradient at D is, we know the gradient at T. And if we can find the gradient at T, then we can find out at which x value does this gradient exist on our cubic function. So that is the whole idea with this. So step 1, find the gradient at d. Now d is this point on the cubic function where we know that the x value is equal to 0, okay, because it's a y-intercept. So let's find the gradient at this point. So we'll use the graph of f and we'll derive it. And once we derive that, we'll be able to find the gradient where x is equal to 0. And of course, that'll be the gradient at d and also the gradient at t. Okay, so we need our graph. Well, we already have the gradient of f. Okay, so this is the gradient of f. Let's just take this as it is and go ahead and find out what will the gradient be where x is equal to 0. So what is the gradient at x equals 0? When you substitute, you realize that you're looking for the y-intercept of the derivative of f, which is just 8. So we can simply tell them, okay, this will be 8. And now that we know that it is 8, it means that the gradient of the tangent, right, at d and t, that they're both equal to 8. Again, how does that help us? If we know the gradient of this tangent is 8, and that one is also 8, then we can find out on this cubic function, where does it have a gradient of 8? It will give us two x values, of course, because it has a gradient of 8 at 2 points at d and t. So let's find out where that gradient is equal to 8. Again, we'll be using this function. We're going to use f prime of x because this is the general gradient of our cubic function. And we're going to find out where is this gradient equal to 8. Okay, so from this equation, if you transpose 8, you see that it will cancel. So 8 is gone on both sides. We might as well take all of this over so that the x squared is positive. So that is 3x squared minus 10x is equal to 0. And now we have to factorize this binomial. So we have a common factor of x. So we're going to take out x as a common factor, and what is left in the first term, we will have 3x. And what is left in the second term? We have negative 10 is equal to 0. So x is equal to 0, or, and here we'll solve for x, you can say 3x is minus 10 is equal to 0, and that's equal to 10, and then divide both hand sides by 3. So x is just equal to 10 over 3. So you see how we got a 0 and we got 10 over 3? That makes perfect sense because we know that the gradient was equal to 8 at 0 over here at d. And now we know the second place is at 10 over 3. The whole point is to find OG. If we know that this happens at 10 over 3, this x value of 10 over 3, we know that the x value of t and the x value of g are exactly the same. So OG is 10 over 3. So we can just conclude that and tell them the x value of t is the same as the x value of g, and that's 10 over 3. Therefore, OG is 10 over 3 units, and that is our answer. Okay, so that is it for this question, and moving on to the next question. Question 8.5 says, determine the value of m if y equals mx plus c. So that's a gradient they're referring to. If this graph intersects f perpendicularly at x equals 5. Okay, so this is a lot like this question. They're using the same idea. So we have the graph of f, which was a cubic function. And they're saying that we need to find m, the gradient of a line which is perpendicular to f at x equals 5. Remember that we had an x-intercept here, an x-intercept of 6. So this line is somewhere where x is equal to 5, right? So it's maybe somewhere here. But they're telling us that that line is perpendicular to the graph of f. So if we had a tangent at this point over here, right, on the graph of f, then that line would be perpendicular to that tangent. Okay, so it's really that same idea. All we're just doing is we need to find out exactly what the gradient of the cubic function is at x is equal to 5. And we find out what that gradient is. That's going to be the gradient of that blue line. That's going to be the gradient of the cubic function at x equals 5. And then we will just apply that it is perpendicular. This line is perpendicular to it. Okay, so we just need the gradient formula again. So let's take that, the gradient of the cubic function. Okay, so this is our function, the derivative of f, the gradient. So we want the gradient specifically at the value where x is equal to 5. So we'll substitute that in here. And that gradient is negative 17. So f prime of 5 is negative 17. So that's the gradient of the cubic function at that point where x equals 5. That gradient is negative 17. Now we know that the gradient of the cubic function at that point is perpendicular to the gradient of this line at that same point. So to find it, we're going to just say the gradient that we have, right, multiplied by the gradient we were looking for is equal to negative 1, because if lines are perpendicular, the product of their gradient is negative 1. So this is negative 17. You don't have to do this long method. You can say times m2 is equal to negative 1, and then solve for that gradient by dividing both hand sides by negative 17. So that would just mean, let's just call that m. The gradient of that line we are referring to is simply 1 over 17. And that is our answer. And that is it for question 8. Question 9 says, a farmer has a piece of land in the shape of a right-angled triangle, and that is OMN, okay, as shown in the figure. He allocates a rectangular piece of land, PTOR, to his daughter, giving her the freedom to choose P anywhere along the boundary MN. Okay, so it means that she can decide to have this land. If P, for example, is over here, then she would have this part. Or she could have it like this if P is over there. And they tell us that let OM be A, so that's the length of OM, since the x value of M is A. And ON be B for the same reason. And P, which is x and y, be any point on MN. And the question 9.1 says, determine an equation for Mn in terms of A and B. So A and B will be included in our answer. So how do we find the equation of this line Mn? Well, we have 2 points on the line. We have M, so we'll call that our x1 and our y1. And we have n, that's x2 and y2. So to find the equation of a line, you first need the gradient. So gradient is equal to y2 minus y1 over x2 minus x1. So this is equal to, and we're going to say y2, which is b. So that is b, this is the gradient of mn, b minus 0, okay, that's the y1, over 0 minus a. And so the gradient of mn is simply equal to, that's going to be b minus 0 is b, and 0 minus a is negative a. Okay, so we can see it's just going to be negative b over a. So the equation of this line can be in the form of y equals mx plus c. So we just need to find c. Okay, what is c? Well, they already told us what this y value is. This is the y-intercept. It's on the y-axis, intersects the y-axis. So this is our c value b. So that means the equation of this line is simply y equals negative b over a, x plus b. And that is our equation. Question 9.2 says, prove that the daughter's land will have a maximum area if she chooses P at the midpoint of MN. Okay, so we have to find that maximum area of that shape, right? PTOR. We have to find the maximum area of that. And this maximum should happen at the midpoint. So in this question, we can either choose to find out where exactly does that maximum area happen, or we can find the midpoint first. And then if they match, then it means that the maximum area does happen at the midpoint. So let's look at what the midpoint is so that we know what we should get. Let's find the midpoint of that line. So the midpoint of line MN, if M is A and 0 and N is 0 and B, let's find the midpoint using the midpoint formula. Okay, so we'll find the midpoint by substituting those points in. And so this will give us that point P, well, supposed P. So we'll just say it's the midpoint of Mn so long. And we have A plus 0 over 2. And this is going to be 0 plus B over 2, which just simplifies to the midpoint of Mn simplifies to A over 2 and B over 2. That's really it. So we're going to find that maximum area. And if it occurs at this point, then we know that she will have the maximum area if she chooses the midpoint of Mn as that point where P is going to be. So how do we find the area first? So we have to find the area before we can find the maximum area. This is the shape that we're looking at, right? We're looking at the area of the shape. So its x value, remember we just found the equation of this line, so it will help us at that point. So we know that the x value is just x, so we'll call that x, that is the length of the side, and the y value is y, but we found y equals mx plus c, so in place of y, we can substitute this as the y value. Okay, so y is that point, negative b over a x plus b. That's what we're going to do. Okay, so what that would mean is we can just write that first. Tell them that P is this point x and the y value is negative b over a x plus b. And now we can finally tell them what the length of these sides are. So OR, that is an x value. Okay, what is that value over there? And that will tell you the length of OR. So that is x. And then OT is the width. So that's the length and the width. Okay, and the width is going to be that y value because you'll go from 0 up by that y value to get that length. Okay, so let's just put down our OR and OT. OR is x, OT is negative b over a x plus b. Now naturally, to find the area of a shape, you say the length times the width, okay, or the breadth. So we're going to do that. So the area of this shape, it was PTOR, right? That shape PT is PTOR. So we'll say area of PTOR is equal to, and we'll say OR multiplied by OT. So this is equal to x multiplied by negative b over a x plus b. Okay, so this is equal to, and we can just distribute. So if we distribute, we get negative b over a x squared, you see it's already quadratic, and then x times b, which is positive xb, and I'll call it bx, so that it's in terms of x. Okay, so this is the area. Let's call it a of x. Found the area. And now, how do we find the maximum area? See how this is a parabola, specifically a concave down parabola, seeing that b over a is a negative value. So to find the maximum of this parabola, this will happen at the turning point. And at the turning point, this is the place where the gradient is equal to 0. So that's what we're going to do. Find the gradient of this function and make it equal to 0. So a prime of x is what we're trying to find. And we'll say coefficient times exponent. So we're going to just say the 2 times the b. So that's negative 2b over a. And then our variable is x. And then 2 minus 1. Exponent minus 1 is 1. You don't have to rewrite that. Then here, when we are deriving, we're saying coefficient times exponent. So plus b. And then exponent minus 1. And that falls away. Okay, so this is the gradient of this function. We want to know whether the gradient specifically is equal to 0. So we'll rewrite that. And now we can finally solve for x. Okay, because right now we're just trying to find out the x value at which this will have a maximum area. Okay, so to find x, transpose the negative value. So that's positive 2b over a. X is equal to b. And then to get rid of this coefficient to solve for x, you can decide to divide both hand sides, but that can be because you still have to sort it out here. It's variables, it's not numbers. So just multiply both hand sides by a over 2b, and then multiply by a over 2b. Okay, so this is x is equal to, and here when we multiply, you see that b is actually in the numerator. That's the natural denominator of 1. So x is equal to, when they cancel, it just is equal to a over 2. And you see how that is the x value of the midpoint that we had. Okay, now just to show that it is that full midpoint, let's go ahead and substitute that x value into our graph mn. Okay, seeing that p is an x value of that graph. So if we substitute it into that, remember it's just going to say y equals and then this y value. Okay, so the corresponding y value is equal to, we're saying negative b over a, and in place of x, we're saying a over 2 plus b, and so y is equal to, here the a's would cancel, and you have negative b over 2 plus b. Okay, now they're actually in terms of the same thing, because this is negative b over 2. You could have written negative b over 2 as negative 1 over 2 b, and then plus b. So this is y equals, and b minus a half b is a half b, which is just b over 2. I'm just rewriting this b, which is already in the numerator. I'm just putting it over there. Okay, so that proves it. You see that the maximum here, right, the maximum area will happen at a over 2 and b over 2, which is the midpoint as well. Okay, which is the midpoint of mn. And so that proves that that maximum area is going to be the midpoint of mn. And that is our answer. And that is it for question 9. Question 10.1 says, a language survey was done with 45 grade 12 learners in Mpumalanga Secondary School, and the aim of the study was to find out what language learners speak in their homes. The results of the survey are listed below. So, 22 speak Afrikaans, 24 speak English, 11 speak Siswati and Afrikaans, 5 speak all 3 languages, and 3 speak only Afrikaans. Then we have 38 learners speak at least one of the languages at home. This is going to be a very important point to note. And lastly, 18 speak Siswati. And then 10.1.1 says, determine the number of learners that do not speak any of the named languages at home. Okay, so if they don't speak any of the named languages at home, just see how they've actually helped us to find this with one of the points that they've mentioned here. So with this one, do you notice that they say 38 learners speak at least one of the languages at home? So you're going to have learners who speak more than one language, but in total, 38 learners speak at least one. So this would include people who just speak only one of the languages, or people who even speak both of the languages, and people who even speak all 3 of the languages. So that number 38 represents everything that is in a circle in the Venn diagram. So that means to find out the learners who do not speak, the learners outside of the circle, you take the total learners, which they told us there are 45 grade 12 learners. Okay, you take that total and then you subtract it by everybody in the circle, which is 38 learners. So we're just going to say 45 minus 38, and that's what's going to give us the learners who do not speak any of the listed languages. So this is 7. So this would be 7 learners, and that is our answer. Moving on to the next question. Question 10.1.2 says, if X learners speak English and Siswati, but not Afrikaans, draw a Venn diagram to represent the information. Okay, so we're going to have our Venn diagram, and we know that we have 3 languages. So we're going to have for English, Siswati, and Afrikaans. Okay, and now let's just pinpoint where that X is. They say, if X learners, okay, these learners speak English and Siswati, but not Afrikaans. So we're looking for the intersection of English and Siswati. Now, if we did that, it would be here, right? We would look at all of this. But then they say not Afrikaans. So you're going to have to exclude anything including Afrikaans. And then there we go. That's where it is. Okay, so we're going to put X down here. And now they want us to draw this Venn diagram. Okay, so let's look at the information and see how we're going to put this in. Okay, so I've pinned the information here. So let's look at that. They say 22 speak Afrikaans. 22 learners speak Afrikaans. Now, what they're referring to is the entire circle of Afrikaans. So we can't put that down yet because we don't even know what the intersections are. So with Venn diagrams, you always start with the intersections. So let's look at where they speak about things happening together. Okay, so here we have 11 learners speak Siswati and Afrikaans. So we're going to go to Siswati and Afrikaans, and that's over here. So you see, it's this entire shaded section. That would be everybody who speaks Afrikaans and Siswati. So what we're going to do is, because we don't have that intersection, that middle, we'll have to hold off on that and see, did they give us information about the middle? Well, they did. They told us that 5 speak all 3 languages. So that's what goes in the middle. Okay, 5 is here. And now that we know a total of 11 learners speak Siswati and Afrikaans, then we know that this must add up to 11. There's already 5 here. So what is left? It would be 6. So that's 5 plus 6, and that makes up the total of 11 learners they were referring to. Okay, now do you see how these intersections in Siswati is filled in already? X, 5, and 6. So now we can consider that they said 18 learners speak Siswati. So in total, they should add up to 18, meaning in order to find out what is here, the learners who only speak Siswati, we will say 18 minus 6 minus 5 minus X. Okay, and that will give us that. So 18 minus 6 is already 12. Then minus 5 is 7. So it's 7 minus X. That's what we'll have here. 7 minus X. Okay, and now we're going to have to look for this intersection, if they said anything about it. Did they say anything else about the intersections that we have? Okay, they don't really say anything about, 2 languages being spoken, but they do say that 3 learners speak only Afrikaans. So if 3 learners speak only Afrikaans, that's what's going to go here. You see how this section doesn't include any of the other circles. So this is for only Afrikaans. And now that we've found this, we can actually find this entire circle of Afrikaans if they told us, how many people speak Afrikaans. So they did. They said 22 learners speak Afrikaans. So this entire circle, regardless of whether they speak English or Siswati, they speak Afrikaans in total. So we're going to add and ensure that everything here adds up to 22. The easiest way to do that is to say 22 minus every other number we see there. So 22 minus 5, that gives us 17. And then 17 minus 6 is 11, and 11 minus 3, finally 8. Okay, so we know this is 8 over here. And now we need to find the learners who speak English only. So they say 24 learners speak English, meaning the entire circle of English should add up to 24. So we'll say 24 minus 8, which gives us 16. 16 minus 5, which gives us 11. And then we'll say 11 minus x. So that's what goes here, 11 minus x. Okay, so that is the entire information of the Venn diagram. We have it down. Okay, and remember that we found out that 7 learners don't speak any of the listed languages, so they go outside. Okay, and yeah, that is it. Because they said we just need to draw the Venn diagram with the given information. So this is our Venn diagram. And moving on to the next question. Question 10.1.3 says we need to solve for x. Okay, now there's 2 ways to solve for x in this case. We could use the fact that we know that the entire Venn diagram consists of 45 learners. So we could add everything up and say it is equal to 45. We could also do it like this. We could add up everything in the circles and say that this will be equal to 38 because they said 38 learners speak at least one of the languages at home. This represents at least one. How many languages do they speak? One language. How many languages do they speak? They speak English and Siswati, so they speak 2 languages. So at least one means the lowest amount of languages they should speak amongst the listed languages should be 1. So everybody here speaks at least one language. So I'm going to use this method to find it. We're going to add everything up and say it's equal to 38. Okay, so that is 11 minus x plus 7 minus x plus 8 plus 5 plus 6 plus 3 is equal to 38. And let's go ahead and put our x's together first. So we can see that these ones would cancel. Okay, they're gone because negative and positive. This is negative x that is left. And let's add the numbers up together now. And they add up to 40. So 40 minus x equals 38. And therefore, if you transpose the negative x, it's positive. And you transpose the 38, that's 40 minus 38. Therefore, x is finally equal to 2. And that is our answer. Moving on to the next question. Question 10.1.4 says, what is the probability that a learner speaks only 2 of the 3 languages at home? So we're specifically looking for learners who speak 2 of these languages. It's not a case where we're saying at least 2, okay? They must speak only 2. So here's what we're going to look at in the Venn diagram. We're going to look for the places where learners speak 2 languages. If we look here, how many languages is spoken here? 1 language, and that's English only. But if we look here, this is an intersection of 2 languages. So that's English and Siswati. So we're going to include that. Now, what about here? This is Siswati and Afrikaans. So we're going to include that. And then 8, that's Afrikaans and English. We can't include 5 because they speak how many languages? They speak 3 languages in total. So we're going to include, that's 2, of course, x is 2. So it's 2 plus 8 plus 6, which is 16. Okay, so that's what we'll tell them, that 2 plus 8 plus 6 is 16. But the question is specifically, what is the probability that a learner speaks only 2 of the 3 languages? So we can say the probability that they speak 2 languages only is equal to 16 over the total learners. So 45 learners in total. Does that simplify? No, it doesn't simplify. 16 and 45 don't have anything in common. So that is our answer. Moving on to the next question. Okay, and now we're on 10.2. So that is the last question for the Venn diagram. And now we are at counting principles. So it says 3 brothers, Owen, Richard, and Robert, are to run a race which has 8 runners in total. The 8 competitors line up 1 to a lane in the lanes numbered 1 to 8. Okay, so we have 8 positions. And 10.2.1 says, write down the total number of possible arrangements of the runners at the starting line. Okay, so the usual first question with these. So that would be, remember, we have 8 positions. Okay, so 8 positions. And we're looking at like this. When the first athlete is placed down, so looking at the first athlete, this athlete would have 8 different positions that they could stand in. So here, 1, 2, 3, 4, 5, 6, 7, 8, right? Now, once that athlete is seated, the next athlete would have how many different positions? There are only 7 left. And then once that athlete is placed down, the next one will only have 6 positions. And then 5 and 4 and 3 and 2 and 1. So that ends up with 8 positions times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 8 factorial. So our answer will be 8 factorial, and we just need to find out what that is. And 8 factorial is 40,320 ways. Okay, so we can just say these are the arrangements. Okay, so that is it for the first question in 10.2. Moving on to the next question. Then question 10.2.2 says, calculate the total number of arrangements in which the 3 brothers are all next to each other. Okay, so the 3 brothers must be next to each other. Okay, this is, we can just use this since we already have 3 stick men. So we can see that as the 3 brothers that we have. Okay, so they need to be all next to each other, meaning they're a group of their own. So we're going to take them like this and then group them in one group. So you guys are a group and then everybody else is just standing. Okay, so let's work with the group first. These three brothers, they are next to each other, but they don't have to be next to each other in this order. Remember, they are three different people: Owen, Richard, and Robert. So Owen, Richard, and Robert. Meaning, Owen does not have to necessarily stand here. Okay, he could stand in Richard's place or Robert's place. So Owen has three choices of positions to stand in. Then after Owen is standing, Richard will have two places to stand in. You can either stand here where you are or here. Okay, so that is 2, so times 2. And then Robert would have one place after Richard is standing in the place, so that's 1. So them on their own, they form 3 factorial. So keep that in mind, 3 factorial. Now let's think about the rest of the other athletes standing. Okay, so these are the other athletes. And so to count their placements, they don't have to be a group. They never said anything about the other athletes need to be in a group. It's only the 3 brothers. Okay, now because they can move around, it'll be easier to explain it from this last person. Let's just say this person now, we're looking at the different positions they can stand in. So they could either be here or here, that's 2, 3, 4, 5, or here in their position. So that first person would have 6 positions to stand in. And then once that person is standing, the next person would have how many positions? Next person would have 5 positions. And then next person would have 4, 3, 2, and then 1. So to account for this, we're going to say multiply by 6 factorial. And that would be it because they're allowed to move around. They're not a group. If they were a group, we would say 3 factorial multiplied by, and then we'll group them together and see that they're a group of 5, and we'll say 5 factorial. And then say that, okay, this group can actually move around. So then we'll say times 2. Okay, so allow them to be in the first or second position. But they didn't say that, okay? The only group created is the brothers. So let's find out what this is. So on our calculator, we press 3 and then factorial multiplied by 6 factorial, which is 4,320. Okay, so that would be the total arrangements that we will have if they were next to each other. Okay, and that is our answer. Moving on to the next question. Question 10.2.3 says, calculate the probability that Owen is in lane 1, Robert is in lane 2, and Richard is in lane 3. Okay, so let's just look at those. So let's just take this like that so we can just look at them. And we're going to put them in those respective lanes. So we're saying Owen is in lane 1. So this is Owen. If Owen must be in lane 1, then that means there's only one position that Owen must stand in. So Owen only has one choice of a place to stand in. And then Robert must be in lane 2. So Robert only also has one choice of a place to stand in, lane 2. And Richard also only has one choice of a place to stand in. So after they are standing in lane 1, 2, and 3, then the other 5 athletes, this is how they will stand. The first of the 5 athletes has 5 different options to stand in. So that's 5 different options. And then after that one is standing, then the second athlete has 4 different options. And then the next one has 3, and then 2, and then 1 option. So that's 5 factorial. 5 times 4 times 3 times 2 times 1. So we just have to find 5 factorial. And let's just check. They specifically said they want the probability. Okay, so the probability would be 5 factorial over the total ways they can stand if there was no restriction. So that was 8 factorial since we have 8 different positions. So what is 5 factorial over 8 factorial? And that would be our answer. And that is 1 over 336 as a fraction. And that is our answer. And that is it for question 10. Okay, so that is the end of this paper. Hope you guys enjoyed it, and I will see you guys in the future videos.